Hello, in this video I'm going to be doing solutions of the exam you see on the screen. Specifically, that's the Cambridge International Maths Exam Paper 2 from the summer of 2023. And that's paper 2-2 to be precise. Now this is going to be quite a long video as it's the entire exam and I go through the solutions slowly on a whiteboard just like you might see in a classroom. So how should you watch this video? Well, you shouldn't watch it first of all. You should attempt a question on your own first. If you're able to do that question, do not watch the solution of the question. Now if you're not able to do it or you need a little help or there's a part of the question you want a bit of help on, then skip to that question in this video and watch it, rewatch it, pause it, rewind, watch it on half speed because I know I sometimes talk a little fast. And then, as I said, if you have any questions, put them in the comments and I'll do my best to get back to you. As I do each question, I'll put the question up on the board just in case you don't have a copy of the questions yourself, but I assume you do. You can find them online without much problems. And remember, you're also going to need a copy of the formula. Again, that can be found online without any problems. From time to time, I will superimpose that on the board as I do the question. With that, let's jump into the questions. This is question 1. In this question, we have to solve this trigonometric function you see on the board. It's secant squared theta plus 5 tan squared theta is equal to 9 plus 17 secant theta. And I'll go ahead and show how to solve this in a moment, but we'll basically get one answer. We're going to get an answer for theta at the end. And these questions pretty much always give you something like this. Tell you theta is between 0 and 360 or any other range they sometimes give you. And that's that should be a clue in your head. Oh, I'm going to get more than one answer. So the one answer we get from this, there's going to be more than that. In fact, sometimes the answer we get when solving these isn't the actual answer. Now you'll get lots of marks for it, but we're going to use this information to get the correct answers. In this question we will get 2 answers, I believe. Yes. Okay, let me dive into it then. The first thing I look at this is I see theta, so I can solve it. There's only one unknown. Next thing I think is I would like everything to be the same. I would like all secant thetas or maybe all tans, or how I did it the first time I tried it was all cosines. But basically you want them all to be the same. So that's the first thing. Actually, yeah, let me talk about the cosine first of all. Secant theta is equal to 1 over cosine theta. Yeah, we're going to need this at the end actually. So how I did it the first time I did, I'm from Ireland, and in the Irish math system we rarely use secant theta. We mostly just use cosine. And so the first thing I did is I turned everything into cosine. So this would be 1 over cosine squared, and tan would be sine squared over cosine squared, and sine squared could be changed into 1 minus cosine squared, and secant changed into cosine. But I understand most students in the CIE system will change everything into secant squared here. Because we also, I'll throw up on the board here the formula table, and as you can see from that, secant squared is equal to 1 plus tan squared theta. Or to write that another way, tan squared theta is equal to secant squared theta minus 1. So I'm going to use this information to rewrite this question up here. So let me just jump right in. Secant squared theta plus 5 times so I'm changing tan squared theta for secant squared theta minus 1, and that's equal to 9 plus 17 secant theta. Okay, what's great now is we only have the one trigonometric function, and that's secant theta. Let me clean all this up so we get how many secant squared thetas? 1 here, and there's 5 here, so that's 6 secant squared thetas. How many on their own? This one here, so let's move that over and we get minus 17 secant theta. And how many numbers? 5 times minus 1 and this 9. So we have minus 5, minus another 9, we get minus 14. All that's equal to 0. Okay, what I've done here is I've reduced all this down to this quadratic equation. We have something squared, something, and just a number. Now lots of students are confused, confused by a function like this. So it's perfectly okay if you want to change this into 6x squared. Secant squared theta, it's just x squared. Minus 17, instead of secant theta, just x. Minus 14. As you get more used to these questions and do more practice on them, they do come up quite regularly. You won't need to do this, you can just leave it as this one here. Okay, so now you've got a quadratic, you just go ahead and solve that. This question does factorize, but it's a hard factorization. So feel free to use your formula, minus b plus or minus b squared minus 4ac, all that square root over 2a with 6 minus 17 and minus 14. You'll get a perfectly good answer out of that. But this does work out as 2x and 3x. Let me remember now. 3 times 7 is 21. 2 times 2, yeah, that's it. 7 and 2. So 3 times 7 is 21x. 2 times 2 is 4x. So 21 minus 4, or 4 minus 21 actually, I suppose. Minus the 21 plus the 4 part. So we get this function. At this point, let me change x back to what it really should be. So instead of x, if we solve this here, it'd be secant theta is equal to 7 over 2. Or here, secant theta is equal minus 2 over 3. Okay, at this point, if your calculator has a function for solving secant, you can go ahead and try and solve that now. You'll get an error for this one, because it can't exist. Now my calculator doesn't have that function. So I'm going to change this into cosine. 1 over cosine theta is equal to 7 over 2, or cosine theta is equal 2 over 7. So really, it basically just flips over when you change it to cosine. So I'll do that here. Cosine theta is equal minus 3 over 2. And this can't exist. Let me just draw cosine here. I like to draw out functions whenever I can. Let me see, there we go. That's all the way up to 360. And this is 1, and this is minus 1. Minus 3 over 2 is 2 spots down here somewhere. So there's no answer. There's no solution to this part of the question. Marker's running out here. So here's the answer we're going to have to solve. Cosine theta is equal to 2 over 7. And let me just squeeze it in here because it's really short part, last part. Put that into your calculator and you will get theta is equal, let me check my notes, 73.4. And theta is equal to 73.4. And at this point, you need to think about all the other answers. So what we found here is cosine 2 over 7. Let me draw that in here. There's 2 answers to that. Calculator will only tell you that. Actually, you know what? Some people probably have fancier calculators, will tell them all the answers. My calculator told me this answer, 73.4. But there's another answer over here. This is 73.4 away from 0. This guy is 73.4 away from 360. So the other answer is 360 minus 73.4, which is equal to 286.6. Okay, that's the answer to question 1. This is question 2. In this question, we're going to be dealing with an exponential function and the logarithmic graph that it makes. Basically, this question simply asks us to find A and B, the values for A and B. Oh, I've left out some things here. They tell us some numbers on this graph. 0.4 and 3.6 is this point. And this point up here is 2.9 and 14.1. Yeah, basically they just want us to find A and B in this question. So how do you go about that? Really, I've thought of 3 different ways. The first idea that came to mind was a really bad one. I threw it out pretty much immediately when I realised how much work it would be. But I might as well tell you now, because a lot of you guys will do the same. Simply, they tell you that x, basically they tell you x is equal to 0.4 and natural log y is equal to 3.6. Let me write that out here. X is equal to 0.4 and natural log y is equal to 3.6. That means y is equal to e to the 3.6. Okay, so this is, I should have mentioned really, this is the first thing you need to be careful of. This is not y. This is natural log of y. And I guess I'll go into more detail in a moment on why that is and basically talk about natural logs versus exponentials. But first of all, real simply, you could put these two numbers in. This number comes out in a calculator. 0.4 and whatever this number is, I don't know, 10 point something. You can put these numbers in as y and x and you get an equation. You could do the same for these two numbers. Get another equation. You have 2 equations and 2 unknowns. You can solve it. It will be a mess. It'll take you half a page, but you will get the answer. That's perfectly okay thing to do. But it's not really the best thing to do. There's 2 other ways to do it, and they both start the same. So let me do that now. First thing I want to say is this graph here. It's graphing this function in a way, and so many things in real life look like this. So many things are modeled by an exponential. How quickly a disease grows, a population growth, financial markets, companies, how quickly they grow every year. They nearly all look like an exponential, and an exponential looks really horrible. It looks like this. It goes up really quick. And what's horrible about that is there might be lots of important information down here that's really hard to see on the graph. Like maybe it goes up a lot here and down a lot there, but it's really hard to see if this is y versus x. So any scientist, or in my job, I look at financial markets. I do not look at graphs that look like this. I click a little button, and most computers have for graphs, click a little button that says put into logarithmic, and the graph turns into something like this. So instead of looking at a company that looks like that, I look at a company that looks like this. Much easier to understand. Oh look, a big change happened here. This wasn't as big a change, and so on. So every scientist, most people who deal with graphs, and it's a lot of people deal with exponential graphs, will use logarithmic over exponential because it looks better. And that brings me on to how to answer this question. It looks better. Instead of using y and x, we use natural log y and x. This question, instead of using y and x, I'm going to change this. I'm going to take the natural log of both sides. The natural log of the left is easy. Natural log of y is equal to the natural log of a e to the power of a minus b multiplied by x. Natural log, how do you get the natural log of two things that are multiplying? They come out like this. Natural log of a plus the natural log of a minus, I'm sorry, I missed the e, of e to the power of a minus b multiplied by x. And then natural logs and exponentials, they destroy each other. And this falls down into just a normal acting number, like adding or multiplying, whatever it's doing. Natural log of a plus a minus b times x. Sorry, it's a natural log of y. So instead of this function with powers, we can turn it into a function like this. Has multiplication, has adding, and it has one or two natural logarithmics. Just like the graph was easier to look at, the functions are easier to work with. This function's hard, this function's a lot easier to work with. So at this point, I'll split it into two ways. I won't do all of the first way, but what you could do at this point is just fill these numbers in. 0.4 goes in for x, 3.6 goes into natural log y. And do it again for these two numbers. You get two functions, and just like I said the first way, you could do it the same, except the numbers will be a lot easier, a lot neater, and you should be able to get the answer out. If you do try that way, be careful not to eliminate b on its own and leave you with a and natural log a. You could solve it, but it's a bit beyond A level. This trick will be on the two functions you get rid of a and b, a minus b completely. Leave yourself just natural log a's, and you should be able to then solve natural log a equals something. And that brings us to the actual way I'm going to show you. Look at this. This should look a little familiar. And these three parts. This should look like the equation of a line. Natural log y, or y. Remember, this is natural log y, not y. So the y-axis. The y-axis is equal to something multiplied by x. Let me write this again. Let me write it as the function you know, y. Although I'm going to add a natural log here. Y is equal to mx plus c. Here's the mx and here's the c. So this is just an equation of a line. The only thing that might confuse students is it's natural log y and not just y. And that's because this function has a natural log y. So noticing that means, because you have 2 points here, you could get the slope of this line. It's just coordinate geometry. You could get the equation of this line. And this is telling me, if you get the slope of that, m is just equal to a minus b. The y-intercept, if you get the equation and find the y-intercept is just natural log. So c is equal natural log a. So noticing this just tells me, instead of doing any maths with this equation, how about I just find the slope and the y-intercept? So that's what I'll do. I'll rub this out to give myself a bit of room. I'll rub this out as well, and I'll leave this equation over here. And then let's just do a bit of coordinate geometry. As a recap of what was important there, I'm saying instead of this equation, we can use the equation we found. Natural log y is equal to a minus b x plus natural log of a. mx, let me write it in even underneath. Natural log y is equal to mx plus c. So instead of doing this maths, which is a little difficult, let's just do coordinate geometry over here. With these 2 points, let's find m. m is equal to, what's the formula? y2 minus y1, 14.1 minus 3.6 divided by 2.9 minus 0.4, and the answer is 21.5. And then I go ahead and get the equation of this line. Now at this point you might use y equals mx, so 21 over 5 times x plus c. You're not going to lose any marks for putting y there, but really it should be natural log of y. Or if this y-axis had something weird, that's what should be there. The equation of a line that you're used to is y equals mx, but really it should be whatever is on the y-axis equals m multiplied by whatever is on the x-axis. And you're not going to lose any marks if you put y here, and you shouldn't even change your answer if you're careful later on. So to find C, I just put in either one of these points, whichever one you want. I'll go ahead and use this bottom one. 3.6 is equal to 21 over 5 times 0.4 plus C. Rearrange that, we get C is equal 3.6 minus 21 over 5 multiplied by 0.4. And we put all of that into a calculator and we get 48 over 25. Write out the equation again. Natural log of y is equal to 21 over 5x plus 48 over 25. Okay, you're getting a lot of marks already. Just to get yourself the last mark, we actually answered the question. So let's go back to here. We want to know A and B. A minus B equals 21 over 5. That's no use to us. We can't solve two things. But natural log A is equal 48 over 25. We can solve that. A is equal to, take the exponential of both sides. A is equal to e to the 48 over 25, and that comes out at 6.82. And then finally, we solve the other one. A minus B is equal to 21 over 5. Or to rearrange all that, we get B is equal to A minus 21 over 5. And put that into a calculator, we will get 2.62. Let me check the answer on another page as well. Oh, different answer for A. Oh no, okay, the answer I'm seeing there is natural log of A is 1.92. And then A is equal 6.82. Okay, so these two are correct. Okay, hopefully that helped, and let's move on to question 3. This is question 3, and in this question we're going to have to integrate to find the area around a curve, or I didn't say underneath a curve because in this case it's going to be above the curve underneath a line. Anyway, they give us a drawing, but I've chosen not to draw it first because I want to draw it with you guys. You don't have to draw it, they've given it to you in the exam, but it's going to help us understand what we're dealing with here. So here's y and x. They draw this curve for us. This curve here looks something like this. They tell us this point here is 2. That's fine, that's that curve. They then tell us there's another couple of lines. There's x is equal to 6, and that just looks like a line straight up like that. Apologies if it's not straight on the board. And they tell us the line y equals 2, and that's just a line coming across like that. So that's where they got this drawing, and they want us to find the area of this curve. Now, whenever you're seeing a curve, it's something that's a bit strange, not a triangle, not a straight line. Triangles are straight lines, I guess. You should be thinking integration. Now you can integrate under a straight line, which I guess I'll show you slightly in this, but really, you see a curve, they ask you area, you should be thinking integration. The problem with that is when you integrate underneath a curve. So if I was to integrate between 2 and 6 of this curve, I would get this area here, something like that, underneath the curve. So that's our first problem, but it's not a big problem because to get the area above, we could just we get this box here. Let me draw it like this. This box, 2 high, 6 long, minus this integration we're going to do will equal the question they want. How does that look? Something like that. So to get this area, we're going to get the area of this box and minus the integration. The integral of this between 0 and 6. Some of you might be thinking, oh, we don't need to do a box or anything. We could just integrate underneath this line and above this curve, and that's fine as well. Let me just write what that would look like, and then I'm going to do it this way. So you could do as an answer, the area is equal to the integral below the line y equals 2, below 2, and above minus above 6 over 2x plus 3. And that would be the answer. Go ahead and integrate this between 0 and 6, and that's going to give you the answer. I'm just going to move this outside and get the answer as 12, because that's what we would get. Between this will come out as 2x, 2x, put a 6 in, you'll get 12. And then I'm going to integrate this guy, and I'm going to get an answer for that. Then I'm going to use the minus, that's where this minus will be. And we're going to get the same answer. So I apologize for not doing it this way. This is how I would do it. It's the shortest maths-like way, but a lot of students I think rather do integrate just once underneath the curve and then do something like this, take away from a box. And it comes up very often. Okay, let me clean this off and we'll do the question. Okay, for the reasons I said there, I'm going to integrate between 0 and 6 of 6 over 2x plus 3 dx. Now lots of students will be able to do this mostly in their head. The integral of something on the bottom row will get a natural log. This 2x will mean we're going to divide our answer by 2. This 6 will just be outside, and that's pretty much it. And that's how I would do it, because I have years of practice on this. But a lot of students aren't that happy. So let me just do it a slightly slower way. I would replace this. Instead of 2x plus 3, I'm going to put a u in there. I'm going to replace u is equal to 2x plus 3. Because this works for really hard questions and medium. I'd call this a medium hard question. But it works, this replacement method works all the time. So I will get u is equal to this. I'm going to end up needing dx. So I'll differentiate u. The u dx is equal to 2. Rearrange this. I get dx is equal to 1 over 2 du. And then the last thing, I need to replace these numbers. When x equals 0, what does u equal? When x equals 0, u is equal 0 plus 3. U is equal to 3. And when x is equal to 6, u is going to equal to 12 plus 3, 15. So instead of doing this question, which some students might find hard, in fact, I can take the 6 outside already. Let's take the 6 out here. Instead of doing this integral, I can go ahead and do this integral. Instead of 0 to 6, I'll go 3 to 15. Instead of 1 over this, I'll do 1 over u. And instead of dx, I will do 1 over 2 du. And again, I can move this half outside here. So this is a lot easier of a question. Well, 6 divided by 2 is 3. The integral of 1 over u, the formula table will just tell us natural log of u, the absolute value of u. And we're going to go ahead and put in 3 and 15 for this. So that'll give us 3 multiplied by natural log of 15 minus the natural log of 3. And then we can clean this up. It's usually you just put this in a calculator, and actually a calculator will clean this for you as well. But this question does ask for the exact answer. So let's clean this up. It also asks for it to be in the exact way. So we'll see how that shows up now in a moment. To clean this up, try and remember your natural log rules. Natural log of something minus the natural log of something is equal to the natural log of 15 over 3 is equal to this, the plus 1, divided by the minus 1. And that's equal 3 natural log 5. And that's where I would leave my answer. It's going to be a problem in a moment. So going back to the start, we still needed the area is equal to 12, that big rectangle, minus this guy here, 3 natural log 5. The only problem is that they asked us to put the answer like this, a minus natural log b. My answer nearly looks like that. Number minus natural log a number. It's just they've no number in front of the natural log. So it's really sad to say, but the examiner probably would take a whole mark away for this. I don't think they're allowed to take away half a mark. If they are, I'm sure they'd only take half a mark, but I don't think they are allowed. So we have to get rid of this tree, but it's not too hard if you know your natural log rules. A number multiplied to a natural log is just the same as a power of the thing inside the natural log. So this is just equal to 12 minus 5 to the power of 3 is 125. Okay, that's the answer to question 3. This is question 4. In this question, we're going to be dealing with functions, graphs, and finding the roots of those functions. Specifically, finding the roots of a function that's very difficult using a computational method. But first of all, they give us this drawing here, and they ask us to, on the same graph, draw this equation. 5x minus 4 and the modulus of that, the absolute value of this. So that's the first part of this question. Draw this, and they also add and show that it has exactly 2 real roots. And first of all, let's deal with the second part. When does it have 2 real roots? Basically, if we draw this and it crosses twice, it has 2 real roots. If it crosses 0 times, it has no real roots. And if it crosses it once, it has 1 real root. Okay, how do we draw this? So let's do that first. Let's take that aside first, just quickly to explain how to draw a function with an absolute value like this. How I would do this is I would ignore the absolute value. I would simply over here draw y is equal 5x minus 4. That's just a straight line. When x is 0, y is minus 4. So minus 4. When y is 0, let me do this one out. 0 equals 5x. Minus 4 goes over. We get a plus 4. 4 plus 0. X is equal to 4 over 5. So somewhere here, that's let's say there's 1. And that's 4 over 5. That would be that drawing. It's not quite what we want. For the modulus says it can never be less than 0. And when it is less than 0, just make it positive. So really what that does is we get some sort of line like this. It just bounces off. This one disappears. And we just take out dots out of it. So that's how that would work. There's a couple of ways we could do this line. One, we could just use symmetry. If it hits a minus 4, it must hit a plus 4. If it has a slope of 5, this slope must be minus 5. That's one way to look at it. Another way is just to say this line here, let's say y is equal 5x minus 4. And this line here is y is equal to minus 5x plus 4. It's just the opposite value of this guy. And ignore anything below the x-axis. Okay, so let's put that in here. There's a couple of problems though. We could just draw it here, but I'm not fully sure where exactly would the lines go. So I would love to know what this point is first. If you didn't get this point and you drew this in the below it or above it, I'm not sure if you'd get full marks or not. You would still show that it has 2 real roots because it doesn't actually matter. Anything in this x positive area will show me the same thing. But either way, let's just find out what this point is. It's quite easy. When x equals 0, e to the power 0 is 1. 3 minus 1 is 2. So we just get the point 2 there. The drawing we're trying to do, let's say 2 would be here, 1 would be here, 4 would be up here somewhere, minus 4 would be down here. So that's enough to draw this line here. Let's say I'd start a dotted, it should be going up to here. A dotted line and then a full line. It's only a sketch, remember, you don't have to be too exact. And then through the 4 0 here. That's a sketch there. Like I said, if you didn't find 2 and you actually drew something like this, I don't think you would lose any marks, but still it's a very easy thing to have found. Put 0 in, very quickly find e to the power 0 is 1, and should have been able to find this point quite easily. Anyway, this is the drawing they wanted, and then they would like a little English probably at this point. They would like to say, well, what would you write in English here? I guess this is what you could do. You could just circle these two. That's probably enough to answer the question, 2 real roots. But I would write something in English. Intersect twice. Therefore, 2 real roots. Something like that. You can write as long a sentence as you want, or like I said, even 2 circles here is probably going to be enough for the examiner in this question. Okay, let me clean up a lot of the board. I'll leave this picture here and we'll go on to the next part. Okay, for part B, they first tell us that these 2 roots, these 2 points here, are named alpha and beta, where alpha is less than beta. So this guy here is alpha. It doesn't really matter for this question. They just say, show by calculation that alpha lies between 0.36 and 0.37. So what they're saying is, if I put a dotted line down here, the first one is 0.37. Let's zoom in on this part. Yeah, something like that. It's just a cross here. If we zoom in, this is 0.36, 0.37. They're just asking us to show by calculation that the root lies between these 2 points. So there's a couple of ways I guess you could do this. Yeah, you could take the difference from these and show that one's positive and one's negative. How I would simply do it is I would take the 2 equations. What are they? 3 minus e to the minus half x, I would assume. And the next equation is the next equation is this one here. This line here is minus 5x plus 4. It's the opposite of this line. It's the one going straight up here. So it has the slope of minus 5. So it's going down, I guess, if you look left to right. And the intercept's at 4. So if I go ahead and just put these 2 numbers in here, by that I mean 0.36 will go in for x. So 3 minus e to the power of minus a half multiplied by 0.36 will get me something like 2.165. And if you put 0.37 in, we will get 2.169. If you put 0.36 into this equation, we get 2.2. And into this one, 3.7 into this one again, we get 2.15. So again, they would like to hear a little bit of English here. They'd like to hear something along the lines of, okay, with the power of editing, I would write something like this. At x equals 0.36, 3 minus e to the power of minus a half x is larger than this. And actually, instead of writing that, I think the examiner would be okay with writing that, but just to be fully correct, I guess I should write that. And again, I could have, yeah, we could go ahead and use that up here. I don't know why I changed that. My notes actually had this, but yeah, that would still get the same answer. Yeah, apologies, that was probably slightly wrong. Yeah, just write something along this line. Again, you don't have to be perfect in the English. You don't even have to write the same thing. You just want to tell the examiner you know what you found here. At 3.6, one is above the other. At 3.7, one is below the other. Therefore, they must have crossed. They must have crossed at some point. So that means the root must be somewhere between these 2 points. Okay, for part C, they ask us to use the iterative formula, this iterative formula that they give us to find beta, the second root up here. Correct the 4 significant figures, and each iteration they want you to show 6 significant figures. This is quite an easy question. All you have to do is fill numbers into the calculator, but still lots of students get confused by that. I think mostly because they don't understand where it comes from, and then they make slight mistakes when doing it. So first let's understand where it comes from. We have the equation, oh I got rid of it here, y is equal to 3 minus e to the minus a half x, and this line here, this time I'll get rid of the modulus and I'll just write 5x minus 4 because I'm only interested in this plus 1 going up. If I just try and put these together, let me do it down here because I don't really need to do this because this is the answer here. If I try and put this together, I would get 5x minus 4 is equal to all this. Minus 4, let's throw it over, we get 7 minus e to the minus a half x. X is equal 1 over 5, 7 minus e to the minus a half x. The same thing they have here. All that you would change is put an n in and an n plus 1. Okay, all this is saying is if you make a guess and an answer, xn, or in our case, we're going to make a guess, x1, and then we're going to get x2, x3, x4, and we're going to stay going until we're finished. They're saying if you put x1 in here, you'll get x2 out here. And that looks, so if you make a guess, any guess really, it looks something like it bounces off and bounces into this point. And I won't go into why that works or how it works. Sometimes it doesn't work. It is interesting. If you're interested in computer science or anything like that, look it up. It's in your book. It's you don't have to go online or anything weird. It'll be in your school book. It's just a small page talking about it. So let's make our first guess. We have a picture here. We can. I don't think my drawing is all that good. Because let me just cheat and see the answer. Yeah, okay, the answer is actually like around 1.3. My drawing looks pretty bad, but let's use my drawing. Let's go ahead and guess the answer is 2.1. Just a little past 2. Again, it's a bad drawing, it's a bad guess, but still. x2 should equal, according to this formula, 1 over 5 multiplied by 7 minus e to the minus a half. And instead of xn, we're going to put in our guess, 2.1. And we put all that into a calculator, which with a bit of editing I've done just now, we get 1.3300. How many? 6 significant figures. So I add 1 more, and that rounds off to 1. And we go ahead and just do this again. Just type it all out. If you're quite good at a calculator, you can get it so you just press equals every time. But it really doesn't take too long. But you just do all of this again, and we will get 1.29715. Do it all again, and you get 1.29544. Do it all again, we get 1.29535. And how many significant figures? They wanted 4 significant figures. So the first 4 here, 1330, and that's different, so we haven't got to the right answer yet. This one's different, we haven't got to the right answer yet. x5. This one's the same. So we're getting closer to the right answer, but 4 significant figures were already there. If I press this again, I get the same 4, which is a bit closer. If I press it again, same 4, a little closer again. And I think, yeah, if I only press another, I guess 4 times more, x9, I already got it so the calculator can't get any closer. Or at least can't show me any closer. Okay, that's what they want there. They want you to, let me just check the answer is correct. Yes, oh, I see an extra digit there, but oh, that's just the range they're happy in. Yeah, this is the answer they wanted. They wanted 1.295. Okay, that finishes up question 4. As always, any questions, ask me below. This is question 5. We're going to continue to look at exponential functions. In this case though, we're going to have to differentiate and we're going to need to find maximums and minimums. We're also going to need to find roots of an equation. And they give us this drawing and this sort of goes down, back up, and it never hits the x-axis. It looks like it tails off. And it crosses at A, it crosses at B, and it has a local maximum at C. First question A asks us to find the gradient, the exact, so not the one, don't want to round off to the nearest decimals, want the exact gradient at point B. So as soon as you hear gradient, one of the first things I do is I get the derivative. Spoiler alert, that's not going to be the first thing you should do here, but still that's what I see gradient, I get the derivative. So we use the product rule. Let's differentiate this one first. We get minus a half e to the minus a half x multiplied by this guy left alone, x squared minus 5x plus 4, and then we leave this one alone, plus e to the minus a half x, and we differentiate this one. That's 2x minus 5. Okay, that's the derivative. And at this point I would think to myself, oh, how do I find the gradient at B? I don't know anything about the point B. So I'd have to start the question again, and I want to find the point B. And the reason I did it this way is because I assume a lot of students out there did the same thing. They seen gradient, they got the derivative, and then they got a little lost. That happens in maths. You're going to have to go back to the start again. So what do we need? We need the point B. What do we know about B? We know it's a root. We know it crosses the x-axis. So we know y equals 0. So let's take this function. Instead of y, let's write 0. 0 equals e to the minus half x multiplied by x squared minus 5x plus 4. Okay, so that means two things multiplied. 0 must equal one of these. Or one of these must equal 0, I guess. And you could go ahead and try e to the minus a half x equals 0, try and solve that natural log both sides, minus a half x equals natural log of 0, but the calculator will give out to you here and say there's no solution to that. Let's just draw a quick e to the minus x, let's see, which way would that go? That would go this way. So it never actually touches the y-axis. So this guy here can never equal 0. So we just basically throw it out. Leaves us just a quadratic, which is good. We're all used to doing quadratics. X squared minus 5x plus 4 equals 0. That should tell us these 2 points. And thankfully this is a nice easy one. We can factorize it. Again, if you're not good at factorizing, use the formula. But this guy works out quite nicely. Two numbers multiply to get 4, and add or take away to get 5. 4 and 1. Minus, both minuses it looks like. That means x is equal to 1 or x is equal to 4. And that works out quite nicely for our picture. That means this guy here is 1, this guy here is 4. So we know what B is. At point B, x equals 4. So now if we want to find the gradient, we can, well, I have room here, let's try it. dy dx at x equals 4. So we just fit that into this equation. The reason I think I'll have room is if you put 4 into this one, 4 squared, 16 minus 20 minus 4 plus 4, 0. I know that because we just found out 4 makes this 0. So this guy's 0. 0 times this guy, that's all 0. Let me do it this way. So we're just left with this is equal. We're just left with this, and we have to put 4 into that. So that equals e to the minus 2, 4 times a half, multiplied by 8 minus 5 is, well, that's 8 minus 5. Let's clean that up. 3e minus 2. And that's how they want the answer. They say exact. You can put that into a calculator. I don't know what it equals. I don't know what it equals, but they don't want a calculator. They want the exact answer. This is how you should leave your answer. You could also go ahead and leave it like 3 divided by e squared. Either one of this is fine. Okay, for the next part, I'm going to be talking about the point C, I think. I better clean up a lot of this. Let's go ahead and leave these two things. They might come in useful. Okay, on to part B, and they ask us to find the exact coordinates of C. So again, C, they tell us is a maximum. You think maximum, you should think derivative or gradient. Same thing. If you think maximum, we should think the derivative equals 0. So this guy here will equal 0. If you ever have equal 0, well, you can go ahead and do it now and move things around, cancel out different. Actually, let's do it that way. Yeah, I was going to say we'd clean this up. Take e to the minus half x out of both sides. Let's put in a big bracket like that. It goes into this one. Yeah, let me finish it this way. I won't use it though. X squared minus 5x plus 4, and it goes into this plus 2x minus 5. And this whole thing equals 0, which means we've already talked about this guy cannot equal 0. So we would just get this equal 0. That's how I did it. But as I look at it, I think it's probably easier for a lot of students to write all of this equals 0. And then let's just move one of them over the equal sign. So we leave this guy where he is. E to the minus a half x multiplied by 2x minus 5 is equals, this comes over the equal side, half e to the minus a half x, x squared minus 5x plus 4. The advantage of doing it this way is we have both sides of the equals, we have the same function, the same value we can divide across. Even better, we can divide because we know it doesn't equal 0, which we already just discussed there. So let's clean this up. Let's multiply 2 across. We get 4x minus 10 equals x squared minus 5x plus 4. Let's get everything over on the right. So x squared is positive. X squared minus 9x plus 14 equals 0. This is a pretty good factorization as well. 7 times 4 works for both of this. 7 times 2, I meant to say. Let's see, they both have to be minus to get minus 9 and multiply to get plus. So we have x is equal to 2 or x is equal to 7. Now, we're looking for C, remember. X equals 2 should be somewhere in the middle of 1 and 4. That's that minimum. X equals 2 would be this minimum here, which nobody asked about, nobody cares about. So the one we're looking for is C. Must be 7. So that's it. Well, let's just mark that one off. So that's the x coordinate. They wanted the coordinates. So we need to. So do not stop now. If you stopped here, you would lose a mark. You do need to go ahead and get y. So let's just do that. I think we might have enough room here. Y is equal to, and we put 7 in. E to the minus 7 over 2 multiplied by 49 minus 35. I'm just putting 7 in here. 7 squared minus 5 times 7 plus 4. And that equals, let's see, 14 plus 4 is 18. 18 e to the minus 7 over 2. That's the y part. I think you would get full marks at this point. But I like to just make sure and write it in coordinate form. 18 e to the minus 7 over 2. Because remember, they didn't ask for x, they didn't ask for y, they asked for both of them. So just put them both together. Again, I don't think you would lose mark once they see 7 and 18 e to the minus 7 over 2. Yeah, just checking that's right, and it does seem to be right. Okay, if you have any questions, put them below and I'll do my best to get back to you. This is question 6, and we're going to be dealing with a trigonometric identity. Then we're going to have to solve a equation, and finally we're going to do some integration. First thing they ask us to do is to show that 4 sine theta plus pi over 3 multiplied by cosine theta minus pi over 3 is equal at all points to the square root of 3 plus 2 multiplied by sine 2 theta. Now, a question very similar to this will come up pretty much every year in the exam. They want you to show that this identity works. Basically, how we do that is we take one of the sides of this identity and we make it equal the other side. We play around with it however we want, but basically we make it equal the other side. You can actually start with either side, although I find it's much easier to take the more complicated looking side. In fact, this question they want you to take this side really, but you could in theory start with the other side. Okay, how do you start? You have a formula table which I'll throw up on the screen right here. In that formula table you have a formula for sine A plus B is equal to sine A cosine B, and so on and so on. That should look a lot like here. It's a sine angle plus an angle. So we can expand this guy out. Again, that formula would have had a cosine angle minus an angle. We can expand that out. Now forgive me, but I wrote this down to save me looking at the formulas all the time. I haven't memorized them. So expanding the sine out, that comes out as a sine of the first angle multiplied by cosine of the second angle plus a cosine of the first angle. Feel free to fast forward this bit, it's just going to be me writing down formulas. Sine of the second angle. All that's multiplied by 4. Then we're going to multiply all of that by something similar here. Let's see, cosine of the first angle, cosine of the second angle, plus sine of the first angle multiplied by sine of the second angle. Okay, that's a big mess. But one great advantage of this is we've got, let me underline them here, sine here, cosine here, sine of this and cosine of this. These are just numbers. You can put these in your calculator. A lot of you may have memorized this. Pi over 3 is 60 degrees. Cosine, I hope I'm not wrong, cosine of 60 degrees is a half. I haven't wrote this down anywhere, so I really hope I'm not wrong. That guy's a half. This guy's square root of 3 over 2. That's a half, and square root of 3 over 2. So we can simplify a lot of this down. In fact, there's a half here, a half here, and a 4 out here. So all of that cancels, all those 2's. The 2 across both of these divide into this 2 times. The 2 across both of these divides into this 2 times. So we're just left with 1. That's the first thing we can do. Next thing, yeah, let's just go ahead and write some of these out. This is sine theta plus square root of 3 cosine theta multiplied by, let's see, cosine theta plus the square root of 3 sine theta. Now, it's not necessarily obvious that we're getting towards the right answer, which is something I'd like to just say quickly. In these questions, it's really not obvious, even for me who has experience doing these. Sometimes I'm like, oh, am I doing the right thing? Have I used the right equation? Am I going to get to the right answer? Often I don't know until the very end. Now, you might be a lot better than me. You might have a lot more intuition for this sort of thing. But honestly, if you are sometimes unsure if you're doing the right thing, don't worry. It happens to all of us. And you know, sometimes you're not doing the right thing. Sometimes you spend 5 minutes and you get nowhere. And you have to start again. Try something else. Start again. Try something else. I do promise more practice. I rarely have to try again. I pretty much mostly go the right way each time. Anyway, what have we got here? We got 2 brackets. Let's multiply them together. See what happens. We'll have sine theta cosine theta. This guy by this guy. The sines, let's multiply them together. Square root of 3 sine squared theta. The cosines together. Square root of 3 cosine squared theta. This will be my first clue I'm going right, because these are going to sort of cancel. Cosine plus sine squared is 1. And then finally the square root of 3's together. They get 3 cosine theta sine theta. Like I said, this guy here, square root of 3 sine squared theta plus cosine squared theta. That's equal to 1. Sine squared plus cosine squared. It's equal to 1 multiplied by square root of 3. So a lot of that's going to disappear. Like, that'll just become 1 multiplied by that. These two are the same. Sine theta, cosine theta, sine theta, cosine theta. I just have them the wrong way around. So there's 4 of them. There's 3 here, 1 over there. So we get, let's see, 4 sine theta, cosine theta plus the square root of 3. We're getting there. Square root of 3 plus 2 times this. Not quite the same still. So let's call up our formulas again. And we can see there we have sine 2 times an angle is equal to 2 times sine the angle times cosine the angle. Just to be clear, that's what we have right here. Sine an angle multiplied by cosine an angle, and that will equal 2 times, sorry, sine 2 times the angle. Okay, I hope that was clear. Let me equal this out. Square root of 3, put it first. Instead of this guy, yeah, let me write it like this. Plus 2 times sine theta cosine theta. And from those tables that were up a moment ago, 2 times sine theta cosine theta is the same as is the same as sine 2 theta. And we have an extra 2 out here. So this guy, this bracket here, is the same as sine 2 theta. So I'll just write this one more time. Square root of 3, plus 2 times sine 2 theta. And that's, you've shown that the right side, the left side, I started with the left and I've ended up with the right side. I hope that was clear. It's honestly, it's hard teaching these things because it's so much writing. I feel like a bit of an idiot writing all this out, and I'm sure it's quite boring to watch. But still, I hope that helped out. And let's move on to part B. Okay, part B asks you to find the exact value of this equation here. Now you can do this without ever doing part A, but how you would do it, well, you can use a calculator. Nowadays, actually, a lot of calculators will give you the exact answer. So be careful on that. You're not going to get any marks if you show no work. Usually if you put a correct answer and show no work, you're fine. This case you won't, because the examiner knows a lot of calculators can do this nowadays. So how you would historically, before calculators, be able to do this question, it's very similar to how you did part 1. You would split both these fractions up into something that was like an angle plus something, an angle minus the something. And you would know that they would cancel out later to get you a much more simplified answer. Now you don't know this is the same as the first one, but it is. They did this on purpose. They wanted you to notice, I wonder if this is anything like up here. It's 4 sine. It's an angle, it's cosine, another angle. And sure enough it is. Let's just write it out like this. Theta plus pi over 3 is equal, let's assume it is equal and see if it works out for us. 17 over 24 pi. Basically this just comes over and takes away. The angle would equal, I have the angle, I have it written down here, so actually let's just do it. 24, multiply that by 8 and multiply the top by 8. 17 minus 8 is 9. 9 over 24 pi. And if we did the same with this guy here, and 1 over 24, pi minus square root of theta minus pi over 3 is equal to 1 over 24. Theta is equal, multiply top and bottom by 8. 1 plus 8 is 9 over 24. So this equation here, this one here, if I rewrite that as 4 sine, instead of 17 over 24, if I rewrite that as 9 over 24 pi plus square root of 3, and then multiplied by cosine 9 over 24 pi minus 1 over or pi over 3. I think I said that wrong again. Sorry, this is the same as this first one we did. It should look very similar to the first one. Now maybe, I don't think I explained how I got there. I think a lot of you guys would have just done that in the calculator, taking this number minus this number and got this, let's say, I don't know what we call it, common factor or something. No, I'm not sure. Not sure what they call it really. But basically, this guy is the same number in both of them, and this one's adding pi over 3, this one's taking away pi over 3. And we learned how to add pi over 3 and how to take away pi over 3 in a function that looks just like this. The answer is right here. So I can just write out the answer is square root of 3 plus 2 times sine 2 times 9 over 24 pi. 2 and the 24 goes in, 12. 9 and the 12 goes in, 3 over 4. Let me write that again then. Square root of 3, 2 times sine 3 over 4 pi. And this one you could put in a calculator and I will tell you what that is. I like to do them myself though a little bit. 3 quarters of pi is about here, and that's the same answer as 1/4 of pi. Pi over 4, and pi over 4 I often just look it up on my tables, and that's 1 over square root of 2. So final answer is square root of 3, missing a plus there, square root of 3 plus 2 times 1 over square root of 2, square root of 2, and that could be your final answer. Or just to make it a little neater, square root of 2 goes into 2, square root of 3 plus square root of 2. Either of these will be fine for your final answer. Yeah, that's the answer to part B. Okay, let me rub this out and we'll do part C. Okay, in part C, they give us this integral, integrate between 0 and pi over 8 of this trigonometric function here that should look very similar to the one we've dealt with all along. Instead of theta, we have 2x. That's the only difference really. So instead of this function, I can write the integral of this guy here, square root of 3 plus 2 times sine. Instead of 2 times theta, it's 2 times 2x. Or instead of theta, 2x should be there. So 2 times 2x is 4x. Put that into a bracket, dx, and 0 to pi over 8. Okay, instead of that integral, this is the integral we're going to be doing. A lot of students are really good at doing functions like this in their head, integration like this in their head. And if you are, go ahead, but I'm going to do it slowly for the students there who aren't very good at it. For example, sine just turns into minus cosine. The 4x in here will just contribute a 1 over 4 to the final answer. And that's all it is, but I'm going to do it a lot slower. So first thing I'll do is I'll separate these, the integral, I'll write all this in later. Whenever these numbers change, I'll write them in. Sorry, square root of 3 dx plus the integral of 2, actually the 2 can stay outside, 2 sine 4x dx. This guy we can do, but this one's a little more difficult. So I like to always, just put a little box here, always substitute. Even when a lot of you will be able to do this in your head, I like to substitute. U is equal to 4x. Du dx is equal to 4. That means dx would be equal to 1/4 du. And let me get a little more room. When x equals 0, u should equal 0. When x equals pi over 8, u is equal 4 times that. So u is equal pi over 2. Okay, instead of doing this question, well, we can do this one straight away. This is square root of 3x. The integral of a constant is just multiplied by x. That's between 0 and pi over 8. But instead of this guy, I'm going to go 2 times the integral of 0 to pi over 2. Instead of sine 4x, I'm going to go sine u. And instead of dx, I'm going to go du divided by 4. And I'll put that 4 out here. Okay, let me continue over here. First, let's leave this until we're evaluating all of them. Square root of 3x between 0 pi over 8. This guy becomes plus a half. Did we lose any minuses anywhere? No, plus a half. And the integral of this becomes minus cosine u. And that's evaluated between 0 and pi over 2. We just go ahead and put all these numbers in. Square root of 3 multiplied by pi over 8 minus square root of 3 multiplied by 0, which is 0. And let's see, minus comes out of this. Minus 1/2 cosine 90 degrees. Cosine pi over 2 is 0. Minus minus, we get a plus. A half, and cosine of 0 is 1. Take your time doing this. So many students make mistakes, especially on the minuses. But just take your time every evaluation. This number minus this number. This number minus this number. Check if there's any minuses in there. Okay, cleaning all this up, we get square root of 3 pi over 8. That's gone, plus a half. And that's it. That's it exactly. Let me just double check. A half square root of 3 over 8. Yeah, that's your final answer for question 6. If you have any comments, any questions, let me know below, and we'll move on to question 7. Question 7 revolves around this set of parametric equations. X is equal to 2t plus 3 divided by t plus 2, and y is equal to t squared plus at plus 1. So we're missing something in this equation. So they tell us a is a constant, and they give us one more clue. They tell it it's given that at the point P on the curve, the gradient is equal to 1. So at P. So if we're ever dealing with P, we know the gradient dy dx is equal to 1. And sure enough, in part A, they tell us, they ask us to show the value of t at P satisfies this equation up here. Very long, messy looking equation. Now your clue should just simply be this: dy dx equals 1. That's a starting point. We can make an equation out of this, and thankfully it does come out looking the same as this. So let's expand this out. dy dx, parametric equations. dy dx is equal to dy dt by the chain rule divided by dx dt. Or you often see it wrote as dy dt dt dx. And both of these we can get quite easily. Let's start with dx dt. Dx dt is, we need the quotient rule, which is the bottom row. So the quotient rule says the bottom row left alone multiplied by the derivative of the top row, which is 2, minus the top row left alone plus 3 multiplied by the derivative of the bottom row, which is 1, or you could leave that blank, divided by the bottom row squared, t plus 2 squared. Let's clean this up. The top row, we get 2t's minus 2t's, that's gone. We get 4 minus 3. So the top row just equals 1, and the bottom row is t plus 2 squared. Alright, let's do dy dt. dy dt is a bit easier. It's 2t plus, remember a is a constant, plus a. I should have squeezed that down there. Let's put this together then. Yeah, hopefully I'll have enough room here. Put this together. dy dx is equal to dy dt, this guy, dy dx. Well, first dy dx equals 1, which equals dy dt 2t plus a divided by this guy here, dx dt. Divide by a fraction is the same as multiplying, flipping it upside down, multiplying. So we got t plus 2 squared. And we just multiply this out and hope, fingers crossed, it looks the same as this, which I believe it does. Let's do this slowly. 2t plus a multiplied by this bracket expanded to t squared plus 4t plus 4, and we'll move the 1 over the equals and we get minus 1, and hell, we'll move the equals down the end as well. Alright, how many t squares do we get? 2t times t squared, sorry, how many t cubed do we get? We get 2t cubed. How many t squares? A t by this t, we get 8 of them. A by t squared, we get a of them, 8 plus a, t squares. And, I wrote them the wrong way around, but that's the same. How many t's do we get? 2t times 4, that's 8, and a times 4t, so that's 8 plus 4a. That's how many t's we get. How many numbers, things with no t's in them? A times 4, 4a minus 1. So 4a minus 1, and all that equals 0, which is identical to this one up here. Okay, that's the answer to part A. For part B, I'm going to need to keep this equation, so let me rub out the rest of the board. Okay, for part B, they tell us that t plus 1 is a factor of this equation here. And then they ask us to find A. Find out what is the value of A. There's a couple of ways to do this. The simplest, though, I will show you. You could divide this into that. We're going to have to do that in part C, or at least we could factorize this, which is what we have to do in part C. But really, the easiest thing, if they tell you this is a factor, then that means t is equal to minus 1, or yeah, to say that better, when this function equals 0, which in part B they don't say it equals 0, when that equals 0, t must equal minus 1. That's what it means to be a factor. So t is equal minus 1 really, for the sake of this. So let's just put that in here. I'll do it up here. So minus 1 cubed is minus 1, so that gets minus 2. Minus 1 squared is plus 1, a plus 8. T is just minus 1, so that gets minus 4a minus 8. Plus 4a is still there, and minus 1 is still there. And equals 0. Because when t equals minus 1, this formula is equal to 0. Okay, we have a lot of things cancel out. 8, take away 8. 4a and minus 4a. So what are we left with? We're left with a minus 3 equals 0, or a is equal to 3. Okay, on to part C. For part C, they say hence show that P is the only point on the curve at which the gradient is 1. Now, interestingly, C is not that difficult of a question, but it is difficult to know what to do. I think a lot of students probably are not sure what to do in this question. So first of all, they say when the gradient is 1. That's what all of this was. That's what this equation up here was. Actually, let me rewrite that with a equals 3. 2t cubed plus 11t squared plus 20t 12 minus 1 plus 11 equals 0. This equation equals 0. This equation works when the gradient is 1. That's what this equation tells us. When the gradient's 1, this is the function that works. So basically any solution to this any solution to this is at gradient equals 1. That's what this is. This is gradient equals 1. So they're show that there's only one point. Show that P is the only point that has gradient 1. Basically they're saying show that there's only one solution to this. And I rubbed it out there. They already told us the solution, t equals minus 1. They're saying show that that's the only solution to this equation. So that's basically what they're asking. Another way to say that is factorize this, find the solutions. So that's a common question in the exam. They would give you a cubic function and ask you to solve it. They'd pretty much always give you one answer. Or at least when it's this simple, make you guess one answer. So basically just solve this, and if they are right, if the question's right, there'll only be one answer. And that means, just to skip ahead, that means we would get when we factorize this more, we'll get a quadratic that we can't factorize, that has no solutions. Anyway, let's go ahead and do that. There's a couple of ways to factorize cubic equations. And my favorite, which, I'll use my favorite now. T plus 1 is the factor we know. I like to divide. Divide this in 2t cubed plus 11t squared plus 20t plus 11. I like to use long division because we don't use it for anything else. But I know other students like to do it other ways. They like to t plus 1 multiplied by something a t squared plus bt plus c. Solve this. A has to be 2. That one's quite simple. And then get all the t squares out. T times bt squared plus 2. So b plus 2 equals 11. Well, b equals 9. And lots of students are really good at doing this in their head. 2t squared plus 9t, and again, you could get, actually c is easy as well. C is 11 plus 11. There we go, I'm done. Still, let me do it this way, even though I've just solved it. I was a bit quicker than I expected. It's quite quick doing it this way as well. T goes into this, or what do you need to multiply by t to get this? Well, 2t squared. And then 2t squared multiplied by this guy back, we get 2t squared. Take them away, we get 9t squares. Take down the next term. Again, you don't have to write all of this. What do you need to multiply this by to get to this? 9t. 9t squared. 9 times 1 is 9t. Take it away, we get 11t. Plus 11, and you can see the answer is 11 up here. Same number as we get down here. Whatever way you do it, you need to get to this. Need to get to this quadratic. Now the next part is to show that this quadratic has no solution. That's what they've told you. Usually you would just try and find a solution, and then you would find, oh, there is no solution. So that's fine. But they've told you there is no solution. So very quick to check for that. Let me do it here. To check if a quadratic has no solution, we just need to go b squared minus 4ac less than 0. If you show for this quadratic, or sorry, this one up here as well, same. If you show that this is less than 0, you're done. You've shown that it has no solution. So let's see, that's b squared is 9 squared, 81, minus 4 times 2 times 11. That's 81 minus 88. That's minus 7 is less than 0. Sure enough, yeah, minus 7 is less than 0. So there is no solution to the quadratic part. This has no solution. This part has a solution that we've already found in part B. And that's the one they were saying, the only one. That's the only solution to this. I hope that was clear. It wasn't meant to be clear for the exam. Remember, the exam was asking you to figure a lot of that out yourself. They expected you to be able to do the maths. The maths you can practice, it comes up all the time. But that was a really good question because they were asking you to understand it so you knew what maths to do. Okay, that's the end of this entire paper. So as I'll always say, if you have any questions, put them below. I'll do my best to get back to you. Thanks for watching and good luck in your exams.